Samantha Ellwood. Thank you everyone for coming and watching mine and my fellow classmates' speeches today. I would take a lucky guess that majority of us in this room today have taken more math classes than we've probably ever wanted to. But how much of the math and equations that we learned from all of our high school, middle school, and even elementary school classes do we actually remember and retain and actually use in our adult lives? Mr. Thalheimer at Will Work at Learning stated that the amount a learner will forget varies depending on many things and factors. We as learning professionals will be more effective if we make decisions based on a deep understanding of how to minimize forgetting and enhance remembering. So for instance, practicing math will make it easier for you to remember and use math later in your life. Mr. Anderson from Quartz also stated when the OECD tested 500,000 15-year-old students around the world in a test known as the PISA in 2012, U.S. teams came in at 27th place in the math category, below their counterparts of Vietnam and Spain, which I personally found very interesting because we, as Americans, usually have to take math all of our lives throughout schooling and college. So for my demonstration speech, I will be demonstrating how to solve two basic algebraic math problems. The first math problem that I will be solving is x squared plus 4x plus 3. So for a problem like this, we will first determine if the problem is factorable. So we will see what is something that will add to get 4 and will multiply to get 3. Any suggestions?
3 and 1.
Good job. So we'll put x plus 3 and x plus 1. And they are positive because positive 3 and 1 times to equal 4 and positive 3 and 1 add to give 3, or times to get 3, sorry. So the point of this problem is to isolate the x to try and figure out what our answers are. So first we will set each equation now equal to 0. So we will go x plus 3 equals 0 and x plus 1 equals 0. So now we will also try to isolate the x by subtracting 3 from each side, which will give us x equals negative 3. And then we will also subtract the 1 from the side, which will give us x equals negative 1. So this is an example of a factorable problem. Alright. And now I will show an example of a problem that is not factorable. The problem is x squared plus x minus 4. So we'll go x squared plus x minus 4. And the point of this problem is you can't find any numbers that will add to give you 1, but will multiply to give you negative 4. So we will now have to use the quadratic formula. I'm sure many of us here have probably learned, and it's been pounded into our brains, what the quadratic formula is. But I will go ahead and write it for example. So it is x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So me personally, I like math, but problems always get more confusing. Yeah, who likes math? But problems always get more confusing when you add in the letters because you're like, letters and numbers, they don't go together. So to find out what your a is, you will look at the first variable. So your a is going to be 1 because it is always understood that an x has an invisible 1 in front of it. So for b, it will be our second variable, which will also be a 1 because there is only an x. And then our c will be the last number, which is negative 4. So now to find our x, all we have to do is plug in these numbers back into our formula. So we will have equals, so we will go -1 plus or minus the square root of 1 squared minus 4, and then we'll plug in the 1 for the a, and then also plug in the -4 for the c, and then we will divide that by 2 times 1. Okay, so now we basically just have to simplify this problem. So when we simplify it, we will get x equals -1 plus or minus the square root of 1 plus 16 divided by 2. And we work all of this out under the radical. And then we just have to solve it even further. I'll move it over here so we have some room. And we'll go x equals -1 plus or minus 17 divided by 2. And then to get the answer to this, it's going to be some weird number with some decimals, so you would just put that in a calculator and plug it back in. But usually they just want you to give it to you like this, because it's harder to put all that back in. But now I have demonstrated how to do both a factorable and a non-factorable problem using the quadratic formula. The quadratic formula is very useful and can also be used on factorable problems to check the answer if you are not sure if it's correct or if you're not 100% sure how to factor. So for instance, for this, we could also take 1 for A, 4 for B, 3 and C, and plug it into this formula, and we would still get -3 and -1. And we do not realize it, but we use these equations in the quadratic formula, maybe not this drawn out, more than we think we do on an everyday basis. According to Mr. Wandery, in everyday examples of situations to apply quadratic formula equations, though they might seem to serve no real practical purpose, they are used on a daily basis to calculate anything. They are used to calculate prices of everything you buy in the store, and to areas or to speeds. In conclusion, thank you all for watching my speech.